I'm going to tell you a little bit about what the company does. I really like Dr. Corey's presentation as well, really kind of outlining sort of how work shapes up in a day and how you can spend your time. So I think I'll try to chat on that a bit too. But really what I'm going to focus on today is diabetes, something you kind of hear a lot about, but want to try to make some sense. San Diego is a big place for diabetes. It's the home of Dexcom, where I spent 6 years of my time. But diabetes, if you probably know somebody in your family or in your class that may have it. It's a lifelong condition that really causes blood sugar levels to become too high. And it's growing like crazy, not only in the US, but all over the world, even here in the UK. So you normally hear about diabetes in twofold. Either you've got like type 1 diabetes, where it's, that's the genetic type, and that affects about 1.25 million people in the US. But type 2 diabetes, and that can be a factor of, some eating and exercise habits, is growing rapidly in the US. That's a big problem. Right now, there's over 34 million people in the US with type 2 diabetes, and that's about 1 in 10 people in the US. That's crazy. That's super high. And so how do you manage diabetes? How do you control these unregulated blood sugars? So number one, what you do is you have to measure your blood sugar. And so normally what that means is you'll prick your finger, you'll get a drop of blood, you'll put it into a blood glucose meter, and you'll measure that. And from there you react. If you have high blood sugar, you'll inject yourself with insulin to regulate that. If you have low blood sugar, you can eat something. But improvements in technology over the past 15 years have really made a big step towards managing blood sugar. And really, the thought here is that being proactive in healthcare is so much greater than being reactive in healthcare. So these two graphs kind of show the major difference in technology, where if you're taking finger sticks 5-10 times a day, you're really not getting a clear understanding of what your blood sugar is doing. And it's tough to regulate that when you only have a single blood point. What's great about this wearable technology is that, believe it or not, I'm actually wearing a product right now. You can hardly see it, but it's there. It's all the time. You forget it. And then it's communicating with your cell phone, and it's tracking. So you can set your own limits there, and your cell phone can alarm you if you're going too high or too low. So it's, you get this active curve that you can be monitoring, which is great. The problem with becoming proactive, this is sort of like the ramp in technology. It's really expensive. And in the US, most of the time, you're kind of blanketed by these costs by insurance. So instead of paying money out of pocket like they do here in Europe, where it's about £50 every 2 weeks, so like $70. Your insurance provider will have to go out and pay that. But it's difficult to justify these costs when these blood finger sticks are they're just so cheap. Secondarily, it's painful. Right now, these sensors, and not always painful, but the sensors go about ½ an inch deep under your skin. So that can, that's where your nerves live, and that can be painful if you're exercising or out surfing or whatever you're up to in a day. And then, it can be a cumbersome technology as well. This is, all of this is monitoring, and not to mention itself, like insulin pumps, which are actively pumping insulin into your body. I mean, those, you might see people with those as well, and they're big pods that you're walking around with. So that's where the company I'm working at really is trying to make our way. And we really believe that this proactive healthcare is the future. We really support, what other companies are doing in this space. But what we want to do is we want to take that next step into technology. So what we're doing is we're developing microsensors that really enable painless and dirt cheap real-time monitoring. So what that means is that we can be 10 times cheaper, so that there's no justification of the cost between out-of-pocket paying between a blood, like if you had the choice of having continuous data versus 10 data points a day or 5 data points a day, and those costs were the same, there'd be no consideration. You would just flock to the more data. So that's really the goal, is to enable people to see how their daily habits are affecting their blood sugar. To be 10 times smaller, so to reduce that pain, that irritation, forget that you have it on. And a lot of times too, diabetes, I had friends with diabetes growing up, and it was, there was this stigma about it that you wanted to keep it private to yourself. I remember in earlier days, teachers were uncomfortable sometimes with students even seeing it. So it was something that, we really want to promote education in diabetes, because it's growing, and it's, the more information, the more we share, I think it's better for everybody involved. And then the future. So glucose monitoring is, that's like the big thing right now in wearable healthcare. But we want to look beyond that as well and say, what else might we be able to measure in real time? So how does that work? What's actually going on in the system? So right now you've got a sensor that's collecting data. It's measuring blood sugar. And basically what that's doing, this is kind of like a realm of the sciences. You have sensors that are resting underneath your skin and creating a chemical reaction with the blood sugar. And what's important there is that, like, chemical reactions are super prevalent under the skin. So we want to be focusing on just blood sugar. We don't want to be distracted by anything else that could cause a chemical reaction. So we've got, like, downstairs now, we've got a team of scientists and chemists and biologists basically optimizing the sensing layer that ensures that we are only reading blood glucose. And then it's going to take that information, it's going to create a little electrical impulse, and it's going to transmit it in this electronic pad that's on your shoulder, or on your forearm at this point, your back arm. And that information is going to be processed through a microprocessor, and it's going to send it via Bluetooth to your cell phone, to the cloud, to whatever data processing that you want, and show you that, it'll process the data and show you your trends over time. From there, then we can really compress and understand the data and provide feedback of saying, hey, you could have an app saying, hey, it's a good time now to consider taking insulin, and this is how much insulin you may want to consider. Or, hey, did you just have a meal? This, you may consider that your blood sugar has been significantly changing by this amount from the meal that you just ate. So it's a way that, we have this kind of, this interaction with healthcare now that I think is a bit stuck in the past. Like, technology is expanding so quickly. We're having the ability to do development like I've never experienced. Even in the past 5 years, I've been in this career path for about 10 years now, and it's just blowing me away how fast technology is advancing. And so to go to a doctor when you're having a problem and say, hey, what is this problem? Force a doctor to try to react and understand what's wrong with you seems like a pretty archaic way to approach healthcare. So what we want to do is empower people to start collecting data and understanding. And we don't want to be pushing decisions into the hands of people, but we really want to promote data as a knowledge-based understanding for healthcare in the future. So what does that mean? How do we break down our team? I'm fortunate to be a part of a really cool, at this point, young team that is just a mix of all different types. So we've got bioengineers. Myself, I'm a mechanical engineer. We've got chemists. We've got biologists, all coming together to design a platform that can sense your blood sugar, make the connections from your sensing to your printed circuit board, change that analog signal to a digital signal, and process and transmit that to your cell phone, where then we have software developers and electrical engineers, human factors people, basically packaging that into useful information for consumers, and then really data scientists and algorithm engineers on the back end to crunch all that. Right now, like you heard, I've recently moved to London, which is a pretty exciting time to be moving internationally in the middle of a pandemic. But I tell you what, this is a beautiful city. If you ever get the chance, I would highly recommend you come visit. And what's beautiful about London is it's really sort of the hub of Europe. You can get all around Europe very easily. That in itself is great because it attracts people from all over the world. It's a very diverse city. So I myself, I grew up in Vermont, but I spent about 10 years in Southern California. We have our head of science is also from the United States. He spent a lot of time up in Northern California. We've got synthetic engineers from Argentina. We've got on the mechanical team English engineers. We've got Portuguese. We've got Italian, French, Indian, Chinese. We've got a very good cultural diversity here at Caura, which is super exciting because it brings a lot of different insights and different ways of thinking. So I'll pause there for a minute because I think that's what I really kind of want to focus on today, is that this type of technology is so exciting because it's kind of like the merging of electrical, mechanical, software, chemistry. It's like where everything kind of comes together into one product. And I think that to me is what seems like such a special moment, is that you can really sort of, when I was in middle school, I knew I was okay at math. I was good at math. I was good at science, but I never was that person to say, this is full on what I'm going to get into. My career was something that developed in time. And as I took a step towards mechanical engineering, and as I took my first job in, at the time, it was a medical implant that I was working on, you start to experience the world of work and how you can be a valuable asset, how you can be a good worker, and how you can start, focusing on the things that can help you develop in your career. For me, that went into manufacturing engineering, and there's kind of this shift of, like, to me, you can be the most incredible engineer, but one of the things I see that as a challenge is communication. So, what I strongly recommend is, focus on whatever type of science you are most interested in. I promise you there are cool projects that you can work on in whatever field you find. But focus also on communicating yourself and challenging yourself to just beyond exploring sciences, explore yourself as a person and what makes you the most effective communicator, what makes you the most easy to chat with. That was something in my mind that made my career 100% easier and more effective, is how to communicate with my peers, how to communicate and focus on making the best possible product. So from here, what's cool is, we're just getting a footprint, we're setting our foot into glucose monitoring. But what's really great is that we've got this ability now to monitor, and we've got a platform that lets us shift to any other analyte that we want to sense. If that's histamines, if that's hydration metrics, if you want to be evaluating how effective your drug, if your medications are performing. We have the ability in a platform, and that's really what our vision is we want to set up a product that can get us out to the market, that can get us selling product and kind of give us some revenue, so that we can really expand into broader horizons and help push technology as a whole. And so I think that's my goal. And really, I think at the end of the day, the technology is beautiful and interesting, and it's challenging. And every day you can, find challenges to overcome. But it's at the end of the day, it's about people. And so putting data back into people's hands and making their life easier and helping them make better decisions for themselves or their loved ones, that to me is making an impact in society.